All right, so recording has started. I'll share my screen also. Very well. So just to show you that there'll be a quiz on Thursday, 31st. So please be ready to compensate the previous quizzes if you didn't get good marks. And even if you got good marks, it's good to practice and to be ready for the final exam. All right, so again, we've discussed this 2 times before, so I'll not spend long time rediscussing it, but we will go through the definitions and just very quickly. So we talked about abstract class, and we said the abstract class, when any class inherits from abstract class using this method, which we call the pure virtual function. All right, you define it, and for example, in this case, let's talk about the example itself, and we implemented this example. We explained it 2 times. This is the 3rd time. So if I have a basic class called shape, and this class is an abstract class, then we should add a function. This this function, virtual function. And when we want to make it mandatory or compulsory for all other classes, subclasses, to implement this, we equate it to 0. If we equate it to 0, we call it pure virtual function. All right. So pure virtual function means it's a virtual function, but it's equal to 0 without any definition. If you can see here, there's no definition for this function. That means any class which inherits or any subclass from this base class should define the virtual function. Otherwise, you will get error. All right. Also here, we took shape, and we want to all the base classes, all the subclasses to define the get area. So void set W, this is a public function, and this is another public function which can be inherited directly, and also double width and height. All right. See here, if when we define the rectangle, class rectangle, public shape, that means class rectangle is a subclass from the public shape, from the class superclass shape. That means we should define the get area here. You don't need to define any other things because it will inherit everything from shape. It will inherit set W, set H, WH, and double W and double H. All right. So in this case, only one thing that we should define is this function, because this is a pure virtual function. So the class here only we returned H times W, which is the area of the rectangle. If we define another class, which is triangle, also is a subclass from shape, also it will inherit the width, the height, the set width, set height, etc. But the area has different meaning here, or different way of calculation. So in this case, we need to define double get area and return W times H over 2, because this is the area of triangle, and of course square, the same, similar to rectangle, only the W is equal to H because it's a square. All right. So also we will have the same, we will define this, and we will have the same. So in general, the abstract class now, it hides the information and shows only the essential information. So everything is hidden here, and in the rectangle, everything is hidden, except for this, you need to define it. All right. So this is the code that we've written, and it's, as I told you, it's editable, so you can copy it and paste it and see how this will be executed. The other important principle of object-oriented is polymorphism. Polymorphism, as I said, I think it's a Greek word, means using things more than once. So I have a function, whatever the function is, f1. Okay, I can use the same function for different types and number of parameters. All right. With example, it will be very much easier. But here also, if you can see here, we use the same function. So it's sort of part of the polymorphism. Here we use the same function, but we didn't pass parameters here. So this is the difference, the main difference, that with polymorphism, we use the same function with different types and parameters. Like you use it every day, the instruction cout. Now, if you pass, let's say, integer x equals 5, then when you pass x, it will be executed. But this is not a function, but just an example of polymorphism. If you define double y equal 1.2, you don't need to use other instruction. You can use it also directly. So it depends on the variables that we pass, the function or the appropriate function will be executed. So using function with the same name but with different functionality. For example, the function double area of double h, double w can be used with different functionality depending on the shape class uses it. In other words, if the shape is rectangle, it will return h times w, otherwise return h times w divided by 2. Now, the easier example is the print. All right. Now, if we define a function, for example, if I define a function void print of integer x, all right, this is a regular function, and inside I put print cout x and end line, all right. Also, I can define another function void print the same name but with different type, double x. All right, cout x end line. All right. Also, I can define the same function void print of double x double y, different number of parameters. Here I have 2 parameters. Then here I can write cout x comma y and end line. All right. Now, if I use any of these function, if I pass, for example, I write print 7, 8, it will come and check that I have 2 parameters. Then it will go and execute this print. If I pass, for example, print 7 is an integer, so it will execute this one. If I put 7.1 is a double, it will execute this one. So based on the type and the number of parameters, it will go and execute the aimed or the appropriate function. In polymorphism, I've created this hierarchy just to show the types of polymorphism. In polymorphism, I have 2 types, compile time and runtime. Okay, in compile time, the types of polymorphism that can be used, function overloading and operator overloading. In runtime, virtual functions. All right, in runtime, we saw it in the area, in the previous example, the virtual function. All right, but here we have a function overloading and operator overloading. Function overloading, as in the previous example, this is a print example, you can use the same function with different number of parameters, different type of parameters, and operator overloading also will be discussed now. So compile time, function overloading, function with the same name but with different number and or type of parameters. If you can see here in the class A, I have public print of integer x, void print of integer x. They are all public. I have the same function print of double x, and I have the same function of integer x, integer y. So according to the parameters that I'm going to pass, it will execute the appropriate function or the mint one. So here, if I, for example, define a variable a of or instance from this class, then when I write a.print of 5, now 5 is an integer, right? So it will go and search for the function that deals with integer. Now, if I implement a.print of 22.15, that means it's real number. It will go and search for the function that deals with real numbers. Now, if I pass 2 parameters, then it will understand that I mean this function, okay? And it will go and execute this function. And this is what we got. The value of x is 5, the value of x is 22.15, and values of x and y are 25 and 35. All right, so this is the compile time. If you get a question, what type of polymorphism is this? This is compile time function overloading. All right. Another example, we are talking about operator overloading. Now, the idea of operator overloading, it's very important and very, it's not that difficult, but it needs some concentration. Redefining the operators. What are the operators? We have plus, minus, division, mod operation, multiplication, unary minus, unary plus, unary when I say minus 5. All right, this is unary, and other operations, of course. All of them can be overloaded, can have different meaning. So redefining the operators to be applied to a specific variable of type defined in a class. For example, now, if you remember, we defined class P point, right? Now, if you have point, let's say 5 and 3, and you have another point, P1, P2, 4 and 5, okay? And I want to find P1 plus P2, I will get error, right? Because I don't have, I didn't define the addition. What was the meaning of the addition without overloading? So what I should do, I should write P1.x plus P2.x and P1.y plus P2.y, right? So that means I will add this one to this one, I'll get 9, this one and this one, I'll get 8, and I will get 9 and 8. Now with operator overloading, I can redefine the plus, this plus, the addition. I can redefine it by using the overloading. See exactly, you don't need to get more instructions, etc. It's very easy to follow this template. So now I have class coordinates. Coordinates mean the same thing like point, because I have x, y, right? The coordinates here, we are talking about coordinates x and y. All right. So the coordinates of private integer x, integer y, public coordinates. This is the constructor, right? Integer x1. Why I put this? To avoid any. This is, remember this. This is the default value. You can remove it, but I put it to avoid any kind of error, default value. All right, because if I don't send this, then I'll get error. All right, so the constructor here is just made to make x equal x1 and y equal y1. This is the constructor. All right, now this is the operation overloading that we are talking about. First of all, the type of the operator, I will write coordinate the same as the name of the, because the return value will be the same type, all right, of the class. Operator, this is a keyword. Then I will put the symbol, the operation that I want to change its meaning, all right, of coordinate, constant, and object. Okay, this is also, see how many times we used the same name of the class or the same type, coordinate, and here also I pass coordinate, constant, and this is a reference number. I think you took it in programming selected language when you talked about the pointers, all right, of object. So here also I have to define, I'll start the function. I have to define coordinate result. Okay, so result.x equal x. What's x is this? This x, all right, plus object dot x, the object that I passed dot x, and result dot y equal y plus object dot y, also y, this y plus object dot y, and return result. So here I change the meaning of the plus. The plus now can be used to add 2 points. We will implement it, and I'll show it to you. Here also I can change the meaning of minus, right? So minus here, coordinate, constant, object, and result.x equal x minus, and here also. Now if you want to change the multiplication, you will do the same here, all right? But in coordinate, the multiplication is different, not only, this is called dot product. I don't want to go in details about this, but soon we will talk about it. So now also I have function void print. This belongs to class coordinate. See out this parentheses, then the value of x and y, and between them this is x, suppose that 5 and 7, and close the parentheses. All right, so this is the operation or operator overloading. Of course, you can overload most of the operation except these operations. Okay, these operations cannot be overloaded. It means you cannot change the meaning of dot to mean something else, or this scope, or this, or size of. All right, you can change the plus, minus, division, multiplication, mod operation, unary minus, unary plus, any operation in your mind can be changed except for these operations. All right, so let's see. This is, of course, when we execute it, coordinate C1 and C2, 7, 5, 12. Here I can create or I can use C1 plus C2. Actually, C1 plus C2, this is overloaded. Okay. And it became, or it will perform 7, 5 plus 12 and 6. In this case, I will get 19 and 11. All right, so this is the result that I will get. Also the minus here. Okay, C1 minus C2, that means 7 minus 12, it will be minus 5, and 5 minus 6, also it will be minus 1. All right, so this is the second type of polymorphism. That means I used the plus sign for different purposes. Before we implement this, let's discuss something which is very important, called the friend function. All right, what's the meaning of friend function? If you remember, when we talked about the private or the access specifier, we say we have private and protected and public, and we said some or the private unprotected cannot be accessed except from inside the class itself or from friend functions and classes. All right. So here, if I have a class and I have a friend function, okay, this friend function can access the private and protected variables and functions of the class. All right. But how to give this permission? How to give the permission to the friend function to access this? Very easy. Just define the function or refer to the function inside the class itself. See here, class A, private X. So X is not possible to be accessed from outside the class except by the class itself or friend classes and functions. So here I declare that, okay, I have a friend function. I have a function which is a friend of mine that can access the value of X. All right. So here also the parameters of the friend function should be the same class. This is very important. Okay. So here I define that, all right, I have a friend function called getX, but it has to take the parameter of the same type, and that's it. This is the end of the class. Right? Outside, I will write integer getX of A. I call it small a, so I can here return a.x. See, actually, we could access the private element or private member of the class A. Now, you can use it anywhere, all right? So this is different. This is not a member, by the way. This is not a member function. Remember, this is a friend function. It's not defined inside the class. If it is not a friend, then outside you have to use this notation, a double colons get x. All right. This is the difference. Here I defined as a friend. That means since it's a friend, it has the access to the private. All right. So this is just to summarize the access operator. And before that, after that, we'll talk about the composition and the class diagram. Then we will start implementing the code. So here, class member access operator dot. This is one of the important operators. If you remember here, when we define the class A, okay, and I have inside integer x, and I have method. Of course, I will make them all public. I have, for example, void print. Okay. Then outside this, I can from the main function, when I declare a variable x of type A, I can use x dot. All right. I can access x and access the. So this is called class member access operator. It means I can access the member by using the dot operation. So x dot. It happens that I gave it the same name. I'll change the name y dot x, and I can use y dot print. Right here, I'm using the print to access the operators of the class. We practiced this many times. All right, arrow. If the object is a pointer to an object, to an object, the two axes to access the class members, we can use this operator, which is the sign of minus and greater than, instead of asterisks and dot operators. See, actually, in when the object is a pointer, it means star x. Instead of using star x or here, let's say a star y. All right. Then instead of writing star y dot x as this one, all right, I can use y arrow x. All right, it's just annotation. Scope resolution. This one is very important, and we talked about it several times. It's used when we define a member function outside a class. The class should contain the operator of the function inside. Now, if you remember, I want to just give me 1 second. I want to add some blank slides. All right. Okay. Now, suppose that you define the class. Let's say I don't want to use only letters. Class student. Okay, and inside the class, I have I make it everything public just for simplicity. Okay, public name, string name. Okay, integer number or ID, and that's it. Okay. Now, if I define here inside the class, for example, string get name. Okay, and that's it. And also I define string set, no, void. It has to be void because it will not return. Set name of string n. All right, and that's it. I close the class, and that's it. Now, the definition, I didn't define the functionality of these functions or these methods, right? So in order to define them outside the class, I should write here outside. Focus that I'm talking about outside the class. I should write here student, then this scope, and write the function here, string get name. All right, and inside here I can write the function like return name. Okay, and this was, if you remember, we took such example exactly in the topic called mutator and successor. Sorry, accessor. Okay, so whatever the function that you defined here, you can define declared here, you can define it outside using this scope operator. So this is also another thing. The colon here is used in inheritance. So now I have one dot, I have colon, I have double colon, and I have this arrow. These are the main operators that are used in classes. Okay. Now the composition. See, I wanted to differentiate between the composition and sometimes it may cause some confusion. Composition and inheritance. I will write it here like class point. All right. So whatever we have, I have. Let's say. All right. Let's make it public. Integer x and integer y. All right. I'll stop here. I will not go in details because I want to make it a bit short. Now, if you remember when I defined the class circle, right? I said I can inherit. Instead of redefine the center, I can take it from point. So in inheritance here, I took the variable x or the features x and y and put it in the circle. So all what I need to do is to define integer radius. Okay, this is called inheritance, and you know it. It's very clear, and we've got a lot of examples about it. Now, what's the difference between the inheritance and the composition? And by the way, there's another part which is the nested. Also, we will try to discuss and see the difference. Now, in composition, yes, I'll define class point. Okay. And I have also public integer x and y. That's it. I will not again write anything more. Now in class circle, there will be no inheritance. See, no inheritance. But what I'll do, the circle needs the center, which is a point, and needs the radius, which is we'll consider it as integer, right? So here I'll define double. Okay. Sorry, not double. Public integer r as a member and point p. See, I used the point as type here, as a variable. I didn't use the inheritance here. If you can see, the difference or the main difference here is here. There was an inheritance. Here there is no inheritance. All right, and here all what I did is to define the remaining. So actually, what is this? What this is equivalent to if I define, for example, here public integer x, integer y, and integer r. This is exactly what the inheritance did. But here, what I did, I used the point as type, as a variable, as a member of the circle. And this is called composition. All right? So the composition, having one class as a member of another class. All right. Example: the point can be center of a circle. So in this case, let's see this example. I will explain, and again we will implement it. So here I have a class point, public integer x, y, and point. This is the constructor x, y, and now in circle. See, I use the point here as a member or as an attribute, right? We call it attribute. I don't like this color. Let me just change it. Okay. So here we have the point as attribute. In addition, I have another attribute, which is the radius. But here in the constructor, okay, see, the constructor, again, if you remember, when we say, for example, in point, we passed x1 and y1, we write x equal x1 and y equals to y1. All right. Here I cannot use p, which is here point I called center. I cannot say center equals p1, or we call it c in this case. All right. Because this needs some preparation and some overloading processes. Here what we do, circle of integer r, point C, then I use this colon and write the center. See the difference, please. This is very important. Here I'm talking about center. And inheritance, yes, in inheritance we used to say circle of, this is an inheritance, okay, integer x, integer y, integer r, all all right? And I used to put this colon and call the name of the class, point of XY, right? Here I'm not calling the class, I'm initiating the center, the instance inside this class. All right, so c.x and of c.x and of c.y, then only the radius. Now how to use this? See, I defined point, p equal point of 1, 3, circle c1 equals circle of 5 and p. Here I used p as what? As a member of the class. Okay. Again, this will be implemented in today's lecture. I think we can implement all these things. If we cannot, then we'll implement part of it today and the rest in the next lecture. But I want you to implement it yourself. See the difference. What is the difference between the inheritance, this in this case, all right? What's the difference between this case and this case? I want you to understand it and to focus on the main differences. Again, one of the important things here, I'm calling the constructor of the point of the original class, and I passed the elements or the parameters of the constructor, while here I'm constructing the center. All right, the center, which is of type point. All right, so here the center equal or of c dot x and c dot y. That means the constructor will construct the center. All right. Finally, which is a very important topic also, I want to explain to you. So we will finish this lecture and we'll start with the practical implementation and with the practical examples. Something called the class diagram. Class diagram, by the way, it's a huge topic. All right, and usually it is discussed or is discussed in UML or unified modeling language. And some other design, and I think in software engineering you will take it. But here, since we are talking about the classes, you should have the basic knowledge of the class diagram. So first of all, this is a class, all right? I want you to represent the class visually or graphically. So basic component of class diagram, I have three, mainly I have three main things in class. If you remember, I have the name, the attributes, and the methods. All right. So for example, if I go to the class point, I will put point as a name. Okay, the attributes, I don't need to put the types, X, Y, and the methods is, for example, return or print, point, okay, read, point, etc. Okay, simple. Here also, a very important thing you need to know about the access modifier. Which one is public, which one is private, and which one is protected. Of course, here we have symbols, all right? We can use, for example, for public, I can use plus. For private, I can use minus. For protected, I use hash, all right? Now, the package and derived class, package is a collection of classes, all right? So derived class will have this symbol and static class underlined. All right, let's see now. If these are private, then I will put minus. Okay. If print is public, I'll put plus. That means I can translate this. maybe in the exam I give you a class diagram and tell you convert this into a class. All right. If I put, for example, the hash symbol here, then I ask you to convert this into class, then you will do this class point, the name. All right. I come here and check that I have minus. That means private. Sorry, here, private. Okay. Integer x, integer y. All right. Then when I finish from these variables, I come here to see the what the methods. Then I find this plus. Okay. All right. Public. Why public? Because plus. All right. Print point. Okay. Of course, it's of type, and write the code that you want. Then I come here. I see I have protected. Then I should write protected. Okay. Read. Of course, read point, and you can write with the type. It's easy, right? Now the inheritance, how to represent the inheritance? When I put this arrow, that means the circle will inherit from point. So if you want now, if I want to implement this, okay, then I'll define the point. The point has private x, private y, public get x, public get y. And when it comes to circle, I'll see that there's an arrow in this direction, then I will write circle. Okay, public point. Okay, and I'll continue with the inheritance. Of course, I'll add private r and public find area and find circumference. All right, so the class point has private attribute x and y, public method get x, get y. The class circle inherits the attribute and the methods from point and has private attribute r, public function. So this is all now about the class diagram. Let's see what we need to implement today. All right, we'll start from the compile time. Yeah, last time, let's see if anybody is texting. All right, there's some old messages. All right, so compile time. Let's implement this and see how to. Guys, I think the fire alarm is on. So just give me 1 second. Let me just make sure that everything's all right. Otherwise, we may end the lecture. 1 second. Is it better? Okay, guys, I'm sorry, but we should end now the lecture. The fire alarm went on, so we have to stop the lecture. I'll see you next lecture. Take care and be safe. All right, bye.